What is a package? A package operates like a folder with files related to each other. In this case, the related files are classes. Every package maintains two purposes. First, it organizes classes as one unit, and second, it controls access to members of a class. A class defined within a package must be accessed through their package name. Access to members of a class, such as variables and methods, are carried out using access modifiers. In this session, we are going to look at package convention and package creation. In Eclipse, we have SRC, which is the source folder that contains source files for our project. It has 5 packages. A package can have sub-packages. Under com.selenium for beginners, I have Java, Selenium Test NG, and utility as the sub-packages. Here's a set of related packages and 3 classes under Java. There's a lot of classes under Selenium Test NG. When it comes to the package convention, if we do not include a package name, then the class goes to default package. For example, right-click SRC, new class. The package field is blank, but we see default in parentheses. This is not recommended. Look what happens when I write class 1 for class name. A warning shows the use of the default package is discouraged. Click finish, and we see class 1 in the default package. Notice how line 1 is blank. I'm going to drag class 1 to Java. Now, line 1 shows a package statement. To create a package, we right-click SRC, new package. By convention, packages must begin with a lowercase letter. If I write capital D for demo package, the warning shows discourage package name. By convention, package names usually start with a lowercase letter. Click finish. It's not wrong, but not recommended to start with an uppercase letter. Delete demo package. Do you see how com.selenium for beginners is different than the other packages? Some projects use a reverse website domain as their package name. If I had a domain called domain called seleniumforbeginners.com, then in reverse, my package would be com.seleniumforbeginners. The dot creates a sub package. Let's create a sub package under Java. Right click Java, new package. Add a dot after Java, then demo package 1, and click finish. Drag class 1 to demo package 1. Dialog shows update references to class1.java. Hit OK, and I realize I misspelled package. So I'm going to right click package 1 and I'm going to refactor, rename, and I'm going to add the E to package and click OK again. Now we see the package has been updated in the statement and in package Project Explorer. The package statement updated to demo package 1. Do you see that? That's it for packages and organizing our classes. Next, I'm going to show you how to access the control features using all 4 access modifiers. And I'll see you in the next video. If you like this video, consider subscribing to my YouTube channel, follow me on Twitter, connect with me on LinkedIn, Facebook, because I have a lot more videos to show you. Just wait, and I have so much more content. And thank you. The 4 access modifiers are public, protected, default, and private. This is the order of their access level. Public can be accessed by code outside its class. Protected is accessed by code outside its package and by code inside its package. If the code is outside its package, then it must be inside of a subclass. Default can only be accessed by code in its package. Last is private, which can only be accessed by code in its own class. Let's pick back up where I left off with packages. A demo package was created under Java. Now I'm going to create one more package. Right-click Java, new package. Demo package 2. We are going to create 3 more classes. Right-click Demo package 1, new class. Name will be class 2. Click the checkbox for public static void main. Right-click Demo package 2, new class. Name will be class 3. Click the checkbox for public static void main. And the 4th class will be under Demo package 2. Name will be class 4. And click the checkbox again. In the same class, all access modifiers are visible: public, protected, default, and private. For class 1, let's write our data variables according to their access level. As a comment, I would write public, protected, default, and private. Same class. First is public int, age equals 20. Second is protected string, birthday equals 02/2020. Third is default, which has no access modifier. Int experience equals 10. Fourth is private. Int ID equals 1, 2, 3, 4. Did you notice the difference in symbols for each access modifier under class 1? Public is a green circle with a white dot. Protected looks like a yellow diamond. Default is a blue triangle, and private is a red square. Let's add some print statements to show the access for each variable inside of a main method. Know what? I have to make the variables static to print their value in the main method. Static for age, public, static for protected string, and default, experience, and private ID. Starting with age, we're going to write sysout public. Age equals the variable name age. Next is sysout protected birthday equals, and the variable name birthday. Third is default. So we write sysout default experience equals the variable name experience. Fourth is private. So we write sysout private ID equals the variable name ID. Let's run. And we see all of the values: age, birthday, experience, and ID in the same package, but different class. Private will not be visible. Let's copy the comment from class 1 and go to class 2 and paste it. Remove private and change same class to same package. Public protected default. There is no need to create an object because the variables are static. Know what? Let's go ahead and remove static from these variables. Copy the print statements and make them a comment. Go to class 2 and create an object. Class 1 obj equals new class 1 obj dot, and we see 3 of the 4 variables: age, birthday, and experience. Private ID is not available. So we go ahead and add the print statements. Add obj in front of each variable: obj.age, obj.birthday, and obj.experience. There's no need to put obj in front of ID because it's not visible. So let's remove this print statement and run. We see age, birthday, and experience. Access modifiers get interesting when dealing with a different package. Only public and protected are visible in a different package. However, protected members are only visible if accessed through a subclass. Go to class 3, and we're going to write as a comment public protected. Different package sub class. We extend class 3. Class 3 extends class 1. Import class 1. Then create an object. Class 3 obj equals new class 3 obj dot. We only see age and birthday, which are the public and protected variables. Let's copy those print statements again, but this time from class 2 and paste them. Let's run. We see age and birthday. Only the public access modifier is visible to the entire project. That includes the same class, same package, different package inside the subclass or inside the superclass. Go to class 4. And write, I clicked the wrong button. That was a mistake. As a comment, write public entire project and extends class 1. Create an object from the superclass this time. Class 1 obj equals new class 1. obj dot import class 1 dot, and all we see is age. Print statement sys out public age equals, then add the obj object name and access age. Let's run. We see age equals 20. This video applied to access modifiers to variables, but it works the same for methods. That's it for access modifiers. If you're interested, subscribe to my YouTube channel, then click the bell icon. The bell icon lets you know when I release a new video. You can also follow me on Twitter, connect me on LinkedIn and Facebook. I have so many more videos to show with our community regarding automation and programming. And I'll see you in the next video.
Books available in paperback, ebook, and PDF. All Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's the Selenium Automation book. And TestNG. Subscribe to get notification of future videos. Don't forget to like, comment, and share.